Our next speaker is Dr. Ioannidis from Stanford. Can you hear us?
I can hear you now.
Okay, we're ready for you. Thank you.
Hear me?
Yes, very well.
Thank you for the very kind invitation. It's a great pleasure to participate in this very interesting workshop. I just want to make sure that the slides are being shared at the moment.
Yes, they are.
Okay. So in trying to describe my experiences on data sharing for clinical research, the best analogy that I could think of is, let's see. I don't think that the slides are moving, though. This is interesting.
Okay, they're on your, what is that, live meeting or WebEx?
So okay, I think now it's working. So the best analogy that I could think of is trying to save books from a burning library. The ancient Greek world collapsed because, to a large extent, one of the main reasons was that it lost control and its scientific records. The Library of Alexandria had about 1 million volumes at its peak. It was burned several times, and now we only have a few fragments and pieces that have survived out of that wealth of scientific knowledge. Currently, we are producing information and data that are equal to several libraries of Alexandria almost on a daily basis. However, most of these data are just presented as a synopsis, an advertisement, I would say, or even an editorial, which is scientific papers in a journal, a few pages that summarize sometimes petabytes of information. So how can we regain that information before it's too late? I have tried to use and retrieve clinical research data and participate in projects that involve data sharing for different purposes. These would be meta-analysis of individual participant data from randomized trials for primary or secondary outcomes on efficacy or harms, exploratory discovery analysis based on existing data such as biomarkers, development and validation of predictive models, methodological work, for example, risk modeling, repeatability and reproducibility checks, and also prospective meta-analysis and networks. Some basic principles is that it's more difficult or sometimes even impossible to unearth the data after the fact, after they have been collected, after the respective paper that describes them, summarizes them, makes an announcement or advertisement about them is published. So I think it's far better to arrange upfront for the full individual level data to be available, and then issues like coding, cleaning, logical queries that sometimes are considered to be a problem, they may take some time, but their difficulty is probably overrated. There's some difficulty of standardization in post hoc efforts that may limit the utility of some of the information, but if we think ahead of time of what exactly we want to collect and what exactly we want to share, this would be less of a problem. Some fields have used principles of data sharing routinely. So, for example, I think one of the major progress, one of the fields that had the greatest progress in the last 10 years has been human genomics, and the reason for that is that there are principles on how to share information at a minimum between all the investigators working on the same theme, and sometimes even more widely with other investigators or making them widely publicly available. I think if we did not have that possibility and that mechanism in place, we would never have materialized the fantastic growth that we've seen in human genome epidemiology or other fields in genomics. I think that clinical trials could learn from such paradigms and try to adopt them. If we take a look at the most highly cited journals, the 50 journals with highest impact factor in the scientific literature publishing primary data on what type of policies they have in place, this is an empirical evaluation that we published last year, And we try to see whether these journals have policies in place for sharing different types of data, whether they have policies for provision of materials and methods and protocols, because otherwise, if you don't really have exactly a sense of what has happened and what the protocol was, it's very difficult to repeat any analysis or make sense of these data sets, and also whether there was a condition of publication that these data should be available. And basically that slide shows lots of color. If you see green color, that's good news. It means that most of these journals have policies in place for sharing data, for making protocols available, and even making a precondition of publication, the availability of that information. However, if you take a look at the last column that has these tiny font numbers, most of these numbers are zeros. And 0 means that 0 out of the 10 papers that we sampled from each one of these journals to see whether the policies were fulfilled actually had activated these policies. So even though there's a lot of interest and a lot of investment in trying to make data sharing to work, in practice I think that we still have some way to go. One of the most interesting aspects of data sharing is trying to see whether one could repeat analysis that have been already done. One doesn't necessarily have to come up with some brilliant new ideas to analyze. Occasionally, just trying to find out whether one could repeat the analysis that has already been published could be very useful and could give us a sense of how well the data sets are functioning if independent scientists are trying to do the same process. And we were very lucky that Nature Genetics and Miles Saxton were looking into the future a few years ago when we decided to do that project. And Nature Genetics, for many years now, has a policy that for microarray types of data, there should be a precondition to publication, a prerequisite to publication, that the information should be available in individual level information, and also the protocol should be available, and everything should be available to independent investigators. So we try to see whether one of the top journals with the best scientists publishing there, some of the best possible studies, whether they could be repeated and reproduced. And practically, 4 independent teams of microarray analysts could reproduce, in principle, only 2 of the 18 tables and figures from different papers that we had probed at that time. Much of the time, the problem was that the information was not available. So even under relatively ideal circumstances, still, the data were not available to be used. Some additional problems that we have encountered in efforts to perform analysis with individual level information include politics. Sometimes people may perceive that this is private information that is boosting their personal scientific career, therefore it's not to be shared because other people will get that same competitive advantage. But I think that there's very little rationale for that. Actually, data sharing would only improve the visibility, credibility, and impact of some research. There's sometimes a clash of evidence-based medicine with expert-based medicine. Both of them are EBM. I think that expert-based medicine remains extremely more powerful compared to evidence-based medicine. Even nowadays, I have a paper with Peter Getze coming out shortly in BMJ on that, on what do you do with involving experts in evidence-based projects, that some of them may involve sharing individual level data. Another issue is that not all data sets may be available at the individual participant level, which means that this generates new possibilities for selective reporting biases, and that could be a serious problem if, for example, there's 50 randomized trials that have been performed on a topic and only 20 of them could be retrieved in individual level information. Then maybe these 20 are a very select sample. Maybe it's only people who believe in a particular type of treatment effect and result that would share their information, and therefore the meta-analysis of these individual level data would be less credible compared to meta-analysis of just summary published information. And I think that all of these problems are largely almost eliminated if sharing of the individual level information is agreed before the data is generated. I think if we wait to see what we can do after the fact, it's very difficult. Finally, I'm showing a slide that seems to be very convoluted, but I think that this is probably what happens in most fields of clinical trial research. The leading paradigm has been that a clinical trial is an island on its own. It can be designed, conducted, analyzed, and published, and we get an answer, and this is it. Most of the time, this is not the case. Usually there's a universe of trials. There's many trials that each one of them may inform the results of the other. And even if you take, for example, neglected tropical diseases, by their name, by default, one would think that these are diseases that no one is doing research on. Actually, there's tons of trials. This is from a paper that will be coming out in BMJ shortly, where with Shanti Kapagoda, I have tried to map the geometry of the networks of trials in neglected tropical diseases, and you see that they're extremely complex. There's all types of comparisons that have been envisioned, and if someone is trying to make sense out of the results of a single trial without having the ability to juxtapose the results of all these other trials and analyzing them with some standardized fashion, it's very difficult to find a final answer. So I think that my reply to the question, do we need clinical data sharing, would be yes, and probably with no qualifications and caveats whatsoever. Thank you.
Thank you very much, and thank you for keeping to time.